Continuing on, another example we have in 2018 survey on climate change, 626 out of 1,278 Americans 18 years or older were extremely or very sure it is happening. Construct a 90% confidence interval for the true percent of Americans who are extremely or very sure climate change is happening. So to construct the confidence interval, hopefully by now we're getting comfortable with that. That is really p hat plus or minus the error. Well, to construct that, first we need the point estimate p hat. We assume that is the 626 divided by 1278, and if I throw this in my calculator, that would be a 0.49. 49% think climate change is happening, and that's out of 1,278 Americans, right? There's over 300 million Americans. We're generalizing a confidence interval for what the percentage of all the 300 and some million that believe climate change have happened. To do that, I need the error, and we know the error is, so if I read the formula out, the error is z sub alpha over 2 square root of p hat q hat divided by n. So I need to find all of those. What we're doing here, we're breaking that into pieces. Z sub alpha over 2 equal, they said 90% confidence interval. Well, that means they want this area to be 90%, right? That means this is 10%, 5% below, and 5% above. And since I have my calculator, I could work backwards. And again, most calculators can only do one-sided. This could do all. So if we go to 0.90 and pretty much leave everything alone, I'll get negative 1.64 and positive 1.64. So z sub alpha over 2 is 1.64. There it is. And let me shrink that a bit. Find the margin of error. The margin of error is z sub alpha over 2, the square root of p hat q hat divided by n. That is 1.64 times the square root. P hat is 49%. That means q hat is 0.51 divided. They asked, how many was it again? I lost track. 1,278, that's n. So if I do this in my calculator, and again, I want to point. So here we're breaking things in pieces, so you could pretty much put everything together. If I take 1.64 times the square root of parentheses 0.49 times 0.51 divided by 1278 and hit equal. I'll get the margin of error to be plus or minus 0.02, and we could go 3. And now construct the confidence interval. Well, that's going to be p hat plus or minus the error. That would be 0.49 plus or minus 0.023. And this, I'm assuming you could put underneath to show you that on a calculator. I already evaluated that. And interpret, what does this mean? I am 90% confident that the true proportion of Americans 18 years or older who are extremely or very sure that climate change is happening is between 46.7% and 51.3%. Note, the interval is small. Do you see that? Since the sample is large. So if I want to use my calculator, this is what I need. I'm not going to do the test yet. I'm going to do that in the next chapters to come. They need X, which is the number of successes. In this case, it was 626. Number of trials, there were 1,200 altogether, 78. And the confidence level was 90%. I could input and just use the calculator. Again, we're not going to do that yet. Looking at the last page of this section, we solve the margin of error to figure out the sample size. So if you want to be this confident, how many people should you ask? That's a very good question. And again, these formulas, I'm already making copies, and you will be handed the formula sheet on every test. For a point estimate, if this is known, this is what you use. N equal Z sub alpha over 2 squared, P hat Q hat over E. If it's unknown, you use this formula. So you don't have a choice. I use one or the other. I don't use both. If P is known, I figure it out, I'm going to use this for sure. If I don't know P, then it has to be this. N is the number of subjects. So it says an economist wants to know if the proportion of children in the United States that speak a language other than English at home has changed since 2016, when 22% of the children did. So initially in 2016, 22% of the children in America spoke a language other than English at home. How many children would we need to be surveyed if the economist wants to be within 2 percentage points, that's the error, of the true proportion with 92% confidence? If we want to be 92% confident, that means alpha is 8%. And a quick sketch will always help. If I want to be 92%, that means this is left with 8%, 4% right there, and 4% right there. Again, our calculator allows us leeway. Other calculators don't, to figure out what the score is. And since I know the proportion, N is going to equal Z sub alpha over 2. I have to get that number. P hat is 22%. That makes this 78%. Divided by the error squared, and the error was 0.02 squared. And we always round up. We never leave it as it is. We round up regardless, because we want to be more confident rather than less confident. Well, I need to figure out the 92%. How does that work? Well, here's my calculator. second distribution, inverse normal. I want a 0.92 and everything else the same. And that's 1.75. So 1.75 there. And there's my n. Let me copy that really quick. There it is. And now if I take n and I plug it in, and let's see what we got. Let's see how we're going to input all of that. I'm going to say parentheses 1.75 squared, right, times 0.22 times 0.78 close parentheses divided by 0.02 squared close parentheses equal. And let me copy that down in the notes so you see exactly what I did. If you have a different calculator, you don't have this calculator, you have to make sure that you use it properly on the homework. This way, when it comes down for the exam, you know how to plug things in. So I'm getting 13 point, whatever the number comes there, I always round up. I want to be more confident, never less confident. So I should ask roughly 1,314 people, and I will be 92% confident that my answer will be within 2 percentage point of the true value. Oh, look at that. What do you know? This was last year, or this was before the last election. It says, before U.S. presidential election, potential candidates have their exploratory team work to determine the percentage of people who will vote for their candidate. Kamala Harris has, so this is true, all of these numbers are true. Kamala Harris had such a team looking into what percentage of people would vote for her. If they wanted to construct a 98% confidence interval, 98%, that leaves us with 1% each, right? With a 3% margin of error, they want the error to be 3 percentage points, which is 0.03. How many people should they ask? Okay, well, let's see. Now, since Kamala Harris never ran for president before, they don't know what P is, and they don't know what Q is. They're trying to figure out how many people should they ask so that they're 98% confident that the answer is true. Well, if I glance at my formulas, I'll notice that I don't have P, I don't have Q for this problem. So I'm going to find n equal z sub alpha over 2 squared divided by 4 times the error squared. And it's not optional. If they gave me the proportion, I must use this formula. If they didn't give me the proportion, that's the formula to use. So how does that work? And here, the assumption, if you use this formula, you're assuming that P hat is 0.50 and Q hat, you don't need to know that, but I'm just telling you this in case it ever comes up for you. Well, let's see. What do I need to know? I need to know the z-score. That's always something I have to evaluate. Oh my God, come on. Okay, here it is. So I'm going to take inverse normal distribution. I want an area of 0.98, 2.33. And there it is. N would equal 2.33. Whether you take the negative or the positive, it doesn't matter because you're going to square it. And the error is 0.03 squared. And no big secret, I'm going to show you how to plug that in the calculator. Actually, let's go the other round because the picture is there. Let's put that right here. if I take, excuse me, 2.33 squared divided by parentheses 4 times 0.03 squared first time so if I plug them in, we would say 1,509 people. That's how many people you should ask. The team would need to survey at least 1,509 voters to be 98% confident that the true percentage of voters who would vote for her is within 3 percentage points margin of error. Right? And oh, I forgot to write this here too. If I wanted to write this one, I will say the economist would need to survey at least 1,314 children to be within here it was 2 percentage points, I believe. Yeah, 2 percentage points of the true proportion of the true P proportion with a 92% confidence. And that's pretty much it for this section.